Ladies and gentlemen, boys and girls, 7.3, angle relationships in polygons. So you've talked about polygons. A polygon is a closed figure with 3 or more sides, okay, straight lines that close a shape. It's a polygon. We dealt specifically with triangles already and quadrilaterals, so you're good at applying the properties of special triangles and special quadrilaterals. You have all of the classifications of triangles by sides memorized and all of the classifications of triangles by angles memorized. There are 3 of each. And you've memorized all of the special quadrilaterals and the properties of each. Yeah?
Yes, sir. Yeah.
Okay. Today we're talking about other properties of polygons, and this is angle relationships and different types of angles. So right off the bat you have 2 pictures there. I've drawn just the outline of the 2 pictures. If you see the lines in yours that I don't have on mine, those lines are added afterward, and I'll tell you why in approximately 4 seconds. Okay, the first image is a convex polygon. Okay? Convex polygon. So we're going to write convex polygon. This is all interior angles measure less than 180 degrees. Now what that means is that we can draw lines across, and we can join 2 lines, we can join 2 vertices, and the line segment will always stay inside the polygon. Okay? So if I join this vertex, this vertice with this one, you know, that line is inside the polygon. From here to here, it's inside the polygon. From here to here, it's inside the polygon. From here to here, it's inside the polygon. Now in the case of a pentagon, it's going to form a standard star. Go ahead and with a different color or with your pencil or a pen, trace those lines. Okay, those are not part of the polygon. They are lines drawn through the polygon, and no part of any line segment that joins 2 points, so no part of any of my red lines falls outside the polygon. They're all inside the polygon, and that occurs when all interior angles measure less than 180 degrees in any convex polygon.
So you're saying all the angles all cannot add up to 180?
No, I'm saying that this angle is less than 180 degrees. This angle is less than 180 degrees. This one, this one, this one, they're all less than 180 degrees. It'll make sense once we combine it with the second note here, which is concave polygon. Concave polygon can have angles greater than 180 degrees. So concave polygon can have angles greater than 180 degrees, and that's what we see here in this angle right here. The interior angle is greater than 180 degrees. And that causes us to be able to take a line segment from one vertex to another vertex, and that line segment is actually outside of the polygon. Okay? So again, the angle, the interior angle, this one is less than 180, this one is less than 180, less than 180, less than 180, but this interior angle is actually more than 180 degrees, right? Because a straight line is 180, and we've clearly gone beyond that straight line. Okay? So this is classified as a concave polygon. Now, could it have more than one angle greater than 180 degrees? Yeah. It could. Okay? What would be a good example of that?
A triangle.
This shape right here. Okay? This interior angle is more than 180, and this interior angle is more than 180. Okay? Concave polygon. We can draw line segments connecting the vertices that fall outside the polygon. So that one has 2.
Do they have to be interior?
the line segments, if they all, oh, the angles that we're talking about, yes. Yeah, we're talking about interior angles, okay? Otherwise, like, we'd be looking at that and be like, oh, that's bigger than 180. Or we'd be looking at that and be like, oh, that's actually smaller than 180. No, it's the interior angles, okay? Maybe underline that and maybe throw that into here. Concave can have interior angles greater than 180 degrees. Okay, with that, you're going to head into your investigation. And we'll just follow the steps, paying close attention. It's similar to the last two that we've done. We're going to make a hypothesis about the sum of interior angles of a pentagon. So if you need to, take a second to look back at your triangle from 7.1, look at your quadrilaterals from 7.2, and take a guess as to the relationship between interior angles or the sum of interior angles in a pentagon. Okay, so you've made a guess. That's called a conjecture, when you're not sure but you think. Now let's do some experimenting. Everyone needs a ruler and a protractor. As per usual, please hurry up if you don't have it. I'm going to continue. In the space below, draw a large, and that should say pentagon. Draw a large pentagon. Okay? Does not have to be a regular pentagon. Can be any old pentagon, 5-sided figure.
Like in the big space here?
Yeah, in the space at the bottom of the page.
How big is it?
And label the vertices A, B, C, D, and E. And go ahead and follow the rest of the directions on there. Step 3, you're going to use a protractor to measure each interior angle and record it on your diagram. For those of us who have forgotten how to use a protractor, you simply line up the bottom line on your protractor along one of the line segments in your pentagon and figure out where that's pointing. Mine is almost 90 degrees. I'm going to say that it is 89. And make sure that you're looking at the correct numbers on your protractor. Go around your whole pentagon, and then number 4 says find the sum of the 4 interior angles. So step 4 asks you to find the sum of the 4 interior angles, so go ahead and add those up.
540.
Check that in your calculator. And if you've helped yourself along the way, you should get that it equals 540 degrees. So the sum of the 5 interior angles in your pentagon should be 540 degrees. Number 5, think about the sum of interior angles in other pentagons. Would it be the same, no matter what kind of pentagon you drew? Sure it would be. We all drew different ones, and we all got 540-ish. 6, draw, this part we should pay attention to together. 6, draw 2 diagonals from one vertex in your pentagon. So that means you're going to choose one vertex, doesn't matter which one, A, B, C, D, E. I'm going to draw them from B. And you're going to draw 2 diagonals. Well, if I go from A to B, that's not a diagonal. But I can draw a diagonal from B to E. So I'm going to pick a different color, and I'm going to do that. And I can draw a diagonal from B to D.
Oh, has to have, like, say, start with B. And
They both have to start at B, or A, or whichever one you choose. Draw 2 diagonals from one vertex.
Oh, from one.
Now the question is, how many triangles did this create?
3, 2,
3 triangles. 7.
I know why.
How do the interior angles of the triangles relate to the interior angles of the pentagon?
I know. Because one triangle equals 180, and the interior angles have to equal 540. So if you do 180 times 3, it's 540.
Nice, Jaden.
Thank you very much, Jaden. Excellent. So 7, the relationship is that if we add up the interior angles of the 3 triangles, which is 180, 180, and 180, that's the sum of their interior angles, we'll get 540, which is the sum of the interior angles in the pentagon. So the sum of interior angles in the pentagon is 3 times the sum of them in a triangle. 8. Extend one of the sides at each vertex, measure each exterior angle. So we've done this before. Go ahead and do that, and then we will add up the exterior angles. Alright, so extend each of your line segments on one end.
Oh, everyone.
Yep. Starting to get a bit messy. And you can cheat a little bit. Should measure them, but you can also just use supplementary angles.
Wait, what's this supposed to add up to now?
Supplement.
All of them. Like all these exterior angles.
Supplementary.
You'll find out if you use your property of supplementary angles, which is 2 angles that add up to 180 degrees. And then go ahead and add up all your exterior angles. I've got 92 plus 91 plus 32 plus 74 plus 71.
Oh, shoot.
Interesting?
3/3. I would say something, but I might get an infraction. So I will keep my.
So go ahead and yeah, what did the exterior angles of a triangle add up to?
180.
Exterior angles 360, and what did the exterior angles of a quadrilateral add up to? 360 as well. And the exterior angles of a pentagon also add up to. So what do you think about the exterior angles of a hexagon? Or the exterior angles of a heptagon, or an octagon, or a nonagon, or a decagon?
They're all.
How are they the same?
Pretty interesting, eh?
A dodecagon.
Alright, if you flip to your next page, page 14, you have a large chart that we're going to fill out at least partly together. And we've learned a lot of these things already, and we're also going to extend our knowledge to hexagons and heptagons. So, let's go down our number of sides, and let's talk triangle. How many sides?
3.
Quadrilateral, how many sides?
4.
Pentagon? Hexagon?
7.
Heptagon? 7. Excellent. Now, the next column has to do with how many diagonals can be drawn from one vertex. So in a triangle, how many diagonals?
Nothing.
What's the
You
diagonal?
can't draw any diagonals. A diagonal is a line that goes from a vertex through the polygon to another vertex. So in a triangle, that answer is 0. Okay? Let's work across now. How many triangles were we able to generate in the triangle? 1. What's the sum of interior angles? 180 degrees. And the sum of exterior angles? 360.
Will
All right.
exterior angles always be 360?
Let's find out.
Yes.
Quadrilateral has 4 sides, so any little quadrilateral. how many diagonals can be drawn from one vertex?
We can't see.
One. You can only get one from one.
You can only draw one diagonal. From any vertex, you can only draw one diagonal. How many triangles did we create? 2. What's the sum of interior angles? Oh, that kind of goes with my 2 triangle drawing, hey? Okay. Sum of exterior angles?
360.
Good. Pentagon. Number of diagonals? We did this earlier. We drew 2. How many triangles did we create? 3. And the sum of interior angles?
360. 540.
540 degrees. Exterior angles?
360.
Let's go ahead and fill in the rest of the 360s, and we're going to actually ignore that column for the rest of this activity. Basically just follow what I said to you earlier, that if you follow all the exterior angles, you're really just going around something once. Doesn't matter how many angles you split it into, you're going around a triangle, or around a quadrilateral, or around an octagon, or a pentagon, or a hexagon. You're going around something once, it's 360 degrees. Okay? So that's the logic there. Let's follow through the rest of this. Hexagon. We haven't done hexagon yet, so maybe just draw a 6-sided figure somewhere at the top of your page. Doesn't have to be regular, but just so that we can think about it. Number of diagonals that you're able to draw from one vertex.
3.
1, 2, 3. And by drawing 3 diagonals, how many triangles you're able to create? 4 triangles.
180 times 4.
So you've got 180 times 4.
720.
I just added 180 to 540.
Good call. Heptagon, you can draw one, or we can just follow our pattern. How many diagonals are we going to be able to draw? 4. How many triangles are we going to be able to make? 5. And what's the sum of interior? 900 degrees. Excellent. So now our goal is actually to create a formula that will tell us exactly the sum of interior angles in any polygon. So that I could say, okay, take a 16-sided figure and tell me the sum of interior angles without following this chart. Okay, 8, 9, 10, 11, 12, etc. Okay? How did we get the answer in this column?
180 times.
What?
180 times 5. No.
From the
Yeah.
So
180 times the number of triangles. Okay? So let's look back again now. Next thing, how did we get the number of triangles? How is it related to the number of sides?
When there's 0 diagonals, there's 1 triangle.
How is the number of triangles related to the number of sides? Let's skip this column. How are these numbers related to these numbers?
Minus 2.
Need sides for
You
triangles.
take away 2 every time. So, pay attention. The sum of interior angles, we take the number of sides, take away 2, and then multiply by 180 degrees. So in any polygon, if we follow this pattern, and they do follow this pattern, we can find the sum of the interior angles by taking the number of sides. So if it's a pentagon, we got 5 sides. Subtract 2, because that will tell us how many triangles we can make. And we know every triangle is 180, so we've got 3 times 180, 540. Okay? So this is a formula that you need to memorize. Box it, star it, highlight it, whatever you need to do.
Before, did you say 5?
The sum, are you looking here?
No,
Or are you up here?
No, keep going.
The sum of interior angles is n minus 2 times 180, where n is the number of sides of the polygon. So the rest of this lesson is simply applying that formula, okay? So we did a couple investigations in order to help us develop that formula. Now we're not allowed to forget that formula. Example 1 says, calculate the sum of interior angles in an octagon. What do we need to do?
8 minus
Excellent. I'm going to write each step, okay, nice and clearly. You're going to do this as well so that you have it in your notes and it goes into your brain. Sum of interior angles is, and I'm going to write it, yeah, we'll stick with the way we did actually. Sorry, I shifted my camera. N minus 2 times 180. Now, in an octagon, what is n? N equals 8.
And then you plug in your
So,
1080.
n equals 8 minus 2 times 180, which equals 6 times 180,
1080.
which equals 1080. 1080 degrees. The sum of interior angles in an octagon. Example 2. Find the measure of each interior angle of a regular octagon. So this is what you just asked. Basically, we just use our answer from example A. We know that since the sum of interior angles in an octagon is 1080 degrees, 1080 degrees. There's two different ways to do it. We're just going to use the formula though, because that makes the most sense. We just take 1080, divide it by how many angles in an octagon?
8.
Divide it by 8, punch that in our calculator,
135.
135 degrees.
For what? For each angle.
So each interior angle,
of a normal octagon.
If they were all the
regular
same.
octagon. So each interior angle of a regular octagon is 135 degrees. Now, another way we could have done that is we could have thought about the exterior angles. What's the sum of the exterior angles in a octagon? 360. So we could have done 360 divided by 8 in order to get that each exterior angle is 45 degrees. And since every interior angle is supplementary to an exterior angle, that would also give us 135 degrees. Okay? That's a different method that you are more than welcome to use.
I agree.
Alright, let's wrap this thing up. Example 3. This time we're not finding the measure of angles, we're finding the number of sides having been given the measure of each angle. Make sure you're still paying attention, guys. So how many sides does a polygon have if each of its interior angles measures 140 degrees? What do we already know about this polygon?
Each thing.
Each angle has the same measure, which means it's
Equilateral.
regular.
Yes.
Why did
Okay? Each side length is the same, each angle is the same, each exterior angle is the same. Here we go. So we know that we don't know how many sides, so we're looking for an n-sided polygon. An n-sided polygon has how many interior angles does an n-sided polygon have? Yeah, you know kind of though.
140. Wait.
No.
How many sides
Just-
does a polygon have?
Well, this has n sides.
Oh, it's a two-sided.
No, it has n sides.
B, C, D, E.
No, don't do that either. If it had 7 sides, how many angles would it have? 7. If it had 4 sides, how many angles would it have?
That's
This one has n
There's
sides.
n sides.
There are, therefore, how many angles?
9.
N angles.
Oh!
That's what we said. We said n.
You didn't say angle.
Okay? An n-sided polygon has n angles, just like a 3-sided polygon has 3 angles, and a 10-sided polygon has 10 angles. Okay? You're right. N is unknown at this point, but it's still going to have the same number of sides and angles. All right, folks? Here we go. If each interior angle measures 140, then their sum in degrees is 140n. We're going to write each of these steps so that you can copy this, so that you can redo them on your own as well. If each int angle measures 140, then the sum of interior angles is 140n. Now, why is that helpful?
You can multiply.
Do we have another formula that tells us
You
the
can
sum of
divide.
interior angles?
Yes.
Oh.
N minus 2 times 180.
The sum of int angles can also be represented by 180 times n minus 2. What does that tell us?
Yeah. We have an n minus 2.
Well, we have the sum of interior angles is 140n, and we have the sum of interior angles is 180 times n minus 2.
24,840.
When A equals B and A equals C, what does that tell me about B and C?
They are related.
B equals C. Okay? So we have the sum of interior angles is 140n, and the sum of interior angles is this. Well, that tells me that 140n is the same as 180 times n minus 2. Okay? Following this logic, if A equals B and A equals C, then B also equals C. Okay? So here we go. We have 180 n minus 2. That's our standard formula for finding the sum of interior angles in any polygon. So that's always going to be true. And in this case, we're told that the sum of interior angles is also 140 times n, because we knew that each angle is 140 degrees. Now all we need to do is perform some basic algebra. What are we going to do first? Our goal in any algebra equation is to get all our variables on the left, all our numbers on the right. So what am I going to do in order to get all my variables and collect like terms?
Add 2 to both
Mine-
sides.
Minus 140.
These guys are stuck in a group.
Minus
140.
140.
Minus
140. Too many people talking.
So I am going to take away 140 n's. I don't have 140, the number 140. I have 140 n's. N, 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 plus N, plus N, plus N, plus N, 140 times. Okay, I don't have 140 ones, 140 n's. But I can't do that first, because these guys are stuck in a group.
Let's say I take brackets away, right?
How do I remove the brackets?
You just take them away.
Take them away.
No, minus.
What does this mean?
Multiplication.
Divide it all.
I have, okay, let's start from scratch, folks.
Minus
We're going to have to
divide
go
one.
back and practice more. All this means, pay attention, 180 times this whole group.
Distribute it.
Thank you, which means I need to times it by n, and I need to times it by minus 2. So here we go. 180 times n, 180 times negative 2. 180 times n gives me 180 n's. 180 times negative 2 gives me minus 360. And the right side hasn't changed yet.
That's
Now, thank you. What do I want to do in my next step?
Add 360.
I'm going to add 360 to just this side, to both sides. And I actually am going to do two things in one step. I'm also going to subtract 140n from both sides. So let's look here on the right. I've got 140n minus 140n, so that's 0. No more n's on this side.
360.
And I'm just left with, I'm just left with 360. It's just a number. It's got no n's. It's got nothing to do with
The
n.
minus the ends.
Yeah, I did that already. I had 140 n's. If you had a
You might
bucket of 140 n's, and I took them all away, there are no n's left on the right. All right, on the left-hand side, I had negative 360. I added positive 360. That gets me to 0. And I have 180 n's, and I'm going to take away 140 of those n's. How many n's are going to be left?
40.
40 n's.
Well, doesn't the n and n cross out?
Nope, because I'm not multiplying or dividing. I'm just subtracting them. I have a bucket with 180 n's in it, and I'm taking out 140 of them. I'm still going to have 40 n's in the bucket. They're not going to magically change into w's or y's or 1's. They're still n's. Now what do I do?
40 divide 40 by both sides or something.
Divide
Divide
both
40.
sides by 40.
9.
Which means on the right,
Right.
on the left, sorry, I'm left with just n.
N
And
equals
over
9.
here, I'm left with
So much more.
So it's the exact same thing that we've been doing this entire time.
how many?
Last unit.
Yeah.
Playing it with Polygon.
Therefore,
Polygon.
a polygon with interior angles of 140 degrees has 9 sides.
Is this like a normal polygon?
Regular polygon? Yes. We figured that out right at the beginning because all its angles were 140
Okay, so you
degrees.
asked us what-
All right, folks, your practice problems come from page 15. Complete them all, please. You can actually do it right on that piece of paper. Make sure you're using your formula. So right at the top of the page, write n minus 2 in brackets times 180 because you're going to be using that over and over again.
What is
Thank you
N?
very much.
I